Hi everyone, I'm Ivan, and today I'm going to be doing number 2 for this discussion post. I'm going to use the alternating series test to see if my infinite series converges. Okay, this is the equation for number 2. So it starts out at 1, and then it goes to negative 1/3, and then positive 1/5, and then negative 1/7, and dot dot dot. So basically, the denominator, it has an equation of 2n plus 1, where the first term starts out as 1. So if n is 0, then the denominator is just 1, and also for the numerator is negative 1 to the nth power. So for the first term, if it's 0, it's just going to be 1 over 1. And every single time, if you noticed, is that if it starts out as a subtraction, then positive, and then subtraction, and then addition again. So these alternating signs tells us that the numerator should start out negative, and depending on the nth term, it will alternate between negative and positive. So this is the relationship between these terms in the series. And basically, we're going to use the alternating series test to see if it meets the condition to say that it's convergent. So basically, the alternating series test tells us that these terms right here, as it approaches infinity, it has to be decreasing, and the term has to approach 0, not just any other number. So basically, in the alternating series test, we take the equation from up here, the full equation. So it would look something like this, right? This is the equation, and we would see the limit as n approaches infinity, but we want to get rid of the sign and also the n beforehand. So it's just going to be 1 over 2n plus 1 for the series test. And from here, we see that it does approach 0, because as n grows larger and larger, the 1 matters less and less. This is the exponent, the dominant function. So we see that it does in fact approach 0 as n goes to infinity. So we see that the numerator grows exponentially, while the denominator grows exponentially as the numerator stays a constant. So we can conclude that the terms are decreasing, so it meets the first condition of the alternating series test, and the term also approaches 0, because as n goes to infinity, the term goes to 0. It approaches 0. So according to the conditions of the alternating series test, this infinite series converges and approaches 0 and meets both of these conditions. So we can conclude that this series is convergent. Thank you for watching.